Hello, sixth graders. This is going to be an extension on repeating decimals. Now you know already what rational numbers are. Because repeating decimals are rational numbers, you can also write repeating decimals as fractions. So here's your key idea for today's lesson. Here are your steps. To write a repeating decimal as a fraction, step 1, write the equation x equals d, where d equals the repeating decimal. Step 2, multiply each side of the equation by 10 to the n power to form a new equation, where n is the number of repeating digits. Step 3, subtract the original equation from the new equation. And step 4, solve for x. So let's walk through an example, and we'll use an example that you already know and use these steps first. All right, so 1/3. Now you all know 1/3 is equal to what as a decimal? 0.3 repeating. So let's use the decimal 0.3 repeating. So we're going to start with 0.3 repeating. So step 1 says, write the equation x equals d. And d is the repeating decimal. So we're going to let d is a repeating decimal. So step 1, here it is. Step 1, x equals 0.3 repeating. All you do is take x and set it equal to the repeating decimal. Step number 2. Step number 2 says multiply each side of that equation by 10 to some power to form a new equation, and the nth power is the number of repeating digits. Well, in this problem, there's only one number that repeats, and that's 3. So I'm going to multiply both sides by 10 to the 1 power, which is just 10. So multiply both sides by 10, that gives me 10x equals, and if I multiply 0.3 repeating by 10, that gives me 3.3 repeating. Now step 3 says, subtract the original equation, which is this one, from the new equation. So we're going to subtract x equals 0.3 repeating. And then step 4 is solve for x. So we're going to take 10x minus 1x, that's 9x, equals. So if I take 3.3 repeating minus 0.3 repeating, that means that cancels. I'm left with 3 minus 0, which is just 3. I now divide both sides by 9. X equals 3/9, which gives me 1/3. So if you follow those 4 steps, you can always write a repeating decimal as a fraction. So let's try a second example. Let's do 0.4 repeating. Step 1, write the equation. So we're going to let x equal 0.4 repeating. Step 2, multiply both sides. Since we only have one number repeating, we multiply both sides by 10. That will give me 10x equals 4.4 repeating. I now subtract the original equation on both sides, and that gives me 9x equals 4. I now divide both sides by 9, and so my answer will be 4/9. Let's try another example. Example number 3, negative 0.23, where the 3 is only repeating. Step 1, x equals negative 0.23, where the 3 is repeating. Now in this example, you still only have one number that's repeating. So we're going to multiply everything by 10. So that gives me 10x equals negative 2.3 repeating. Now I subtract the original equation, notice I lined up the decimal, Now here's where you got to be careful. When we go back to the first two examples, we subtracted just a positive number, but we still subtracted. It's always important to notice that when you subtract, you're subtracting the x and you're subtracting this, which means you are subtracting a negative. If you are subtracting a negative, this becomes a positive. So you're actually taking negative 2.3 repeating, and you're subtracting a negative, which means you're adding 0.23. So on the left side, we are going to get 9x. But on the right side, I'm going to do this off to the side. Notice how you have this. You have 3 repeating and a 2. Well, I can't subtract that, so we're going to write that out one more digit. Since the 3 repeats, you can write it like this. And since you're adding 0.23, which is our original one, notice how we lined up the 3 repeatings? They cancel. So now, since these are different signs, I have to subtract them. So negative 2.3 plus 0.2 will give me negative 2.1. So I have negative 2.1. You now have to divide both sides by 9. X equals. Now you cannot have a decimal within a fraction. So this would be negative 21 90ths. Once again, you got to make sure it's simplified. Well, 3 goes into both 21 and 90. So if I simplify negative 21 90ths by 3 in the numerator and denominator, you would get negative 7 30ths as your fraction. And once again, remember, you can always divide this and see if you get the original decimal. That's an easy way to check to make sure you're getting the right answer. Now in example number 4, we now have 2 repeating digits. So step 1 is still the same. Let x be your repeating decimal. The next step is multiply both sides by 10 to the n power. Remember, 10 to the n power, this is the number of repeating digits. In this case, we have 2. So you're going to be multiplying both sides by 10 squared, which means you're going to be multiplying by 100. So you're going to take 100 times x, that gives you 100x. 100 times 1.25 repeating is going to give you 125 and then 0.25 repeating, because the decimal has to be moved to the right. You're multiplying by 100. We subtract our original equation. Now here, remember what I said before. The parentheses, while they're important, here you understand that if you distribute the negative, it's just minus. So when you don't have a negative in front, it's pretty easy, but always make sure if there's a negative right here, it's going to turn to a positive. So in this case, 100x minus 1x is 99x. Now we subtract. Notice the 0.25s disappear. So this would give me 124. I divide both sides by 99. So you can leave your answer as 124 99ths, or you could change it to a mixed number, which is 1 and 25 99ths. Either one of these would be an acceptable answer. I want you to try number 5 yourself. Pause the video and do this yourself. 3.21 and the 21 is repeating. If you simplify this, 318 divided by 99, you're going to get 106 divided by 33. Or you could write it as 3 and 7/33.